we're going to use the distributive property to solve word problems. This is going to be similar to what we did when we wrote our equivalent expressions, but we're going to take that expression and interpret it in order to answer our word problem. Let's start off. Graham has 56 pieces of candy and 42 toys. He wants to create goodie bags for his party that have the same combination of candies and toys in each bag without having any leftovers. And we want to describe all the different goodie bags that we can make. Now, this problem we can tell is a problem that's going to involve factoring because he has a set number of pieces of candy and toys, and he wants to break them into different groups, and that's what we do when we factor. So the first thing I'm going to do is I'm going to take my pieces of candy and I'm going to factor them. Now, it's really important when you're doing word problems that you label everything so that your numbers make sense. So 56 is going to be 1 times 56. It's going to be 2 times 28. It's going to be 4 times 14. And it's going to be 7 times 8. Now we're going to factor our toys. And again, don't forget your label. There are 42 toys. So that's 1 times 42, 2 times 21, 3 times 14, and 6 times 7. Now, before we go ahead and describe these bags, what I want to do is I want us to circle all of our common factors. Okay? 1 is always going to be a common factor, but in answer to this question, it doesn't make a whole lot of sense. He wants to make goodie bags for his party. We know he could make one group and put everything in it, but that's not what you would do for a party. So what we're going to do is we're going to look at all the other common factors. So we have a common factor of 2, we have a common factor of 7, and we have a common factor of 14. Now before we describe the bags, let's look at this common factor of 2 and think about what we know with writing equivalent expressions. Since 2 is our common factor, if I were writing an equivalent expression, that would go outside my parentheses. And then inside my parentheses would go these 2 matching factors, 28 and 21. But let's think about what that means in terms of this word problem. This 2 tells me how many groups he can make, or in this case, how many bags. He can make 2 groups. Inside those groups are going to be this number of things. Now the 28 came from over here, so that's 28 pieces of candy. And the 21 is here, that was 21 toys. So what this expression tells me is he can make 2 bags that would have 28 candies and 21 toys. So if you can create your equivalent expressions, you can then describe them based on what the word problem means. So you see we have this common factor here of 7. That means he can make 7 bags. And inside those 7 bags would be 8 candies and 6 toys. And we also see that we have a common factor of 14, which means he could make 14 bags. And in those bags he would have 4 candies and 3 toys. All right, let's look at another problem. Amanda is making cookies to give to her neighbors. She has 60 chocolate chip cookies and 48 snickerdoodle cookies. Amanda wants to create plates with the same combination of chocolate chip cookies and snickerdoodle cookies on each without having left over. And what we want to know is how many different kinds of plates can be made, and we want to describe them all. So again, let's start with our chocolate chip cookies, chocolate chip. And we have 60 chocolate chip cookies. So let's factor that. I've got 1 times 60. I've got 2 times 30. I've got 3 times 20. I've got 4 times 15. I've got 5 times 12. I'm kind of running out of room here. And I've got 6 times 10. Now I also know that I have snickerdoodle cookies. Okay, and I have 48 snickerdoodle cookies. That's 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. So again, let's look for these common factors. We're not going to use one because we know she could put everything on one plate. But she could make 2 plates. If she made 2 plates, there would be 30 chocolate chip cookies and 24 snickerdoodle cookies. Let's move those down just a smidge so we can see them better. All right, she could also make 3 plates because we have a common factor of 3. And if she made 3 plates, they would have 20 chocolate chip cookies and 16 snickerdoodles. All right, we have a common factor here of 4, which would mean 4 plates with 15 chocolate chip and 12 snickerdoodles. We have a common factor of 6, which means she could make 6 plates. And those 6 plates would have 10 chocolate chip cookies and 8 snickerdoodles. And finally, the last common factor that we have is 12. So that means she could make 12 plates, and those plates would have 5 chocolate chip cookies and 4 snickerdoodle cookies. And that's how your distributive property can be used to help you figure out word problems.